Welcome back to Kubernetes Crashcasts. I'm Sheila, and as always, I'm joined by the knowledgeable Victor. Before we dive in, I want to remind our listeners that if you're enjoying our show, please rate us on your favorite podcast platform. It really helps us reach more people who want to learn about Kubernetes. Now let's get started with today's topic, Kubernetes components. Victor, I've got a quiz question for our listeners. What component of Kubernetes is often referred to as the brain of the cluster?
That's an intriguing question, Sheila. It really makes you think about the different parts of Kubernetes and how they function together. Without giving away the answer, I can say that this component plays a crucial role in managing the overall state of the cluster. Listeners, keep this question in mind as we discuss the various components, and we'll reveal the answer at the end of the episode.
Great! Before we dive deeper, let's quickly recap where we are in our Kubernetes journey. We're in the first season, Introduction to Kubernetes, and we're currently in the fourth chapter, Understanding Kubernetes Architecture. We've already covered what Kubernetes is, gotten started with containers, and set up our environment. Now we're ready to explore the inner workings of Kubernetes. Victor, could you give us an overview of what we mean by Kubernetes components?
Certainly, Sheila. Kubernetes components are the essential building blocks that make up a Kubernetes cluster. They work together to manage containerized applications across multiple machines. These components can be broadly categorized into two groups: the control plane components, which make global decisions about the cluster, and the node components, which run on every node and maintain running pods.
That's a great starting point, Victor. I've heard the term control plane before, but I'm not entirely sure what it means. Could you elaborate on that?
Of course. The control plane is like the brain and nervous system of Kubernetes. It's responsible for making global decisions about the cluster and detecting and responding to cluster events. The main components of the control plane are the API server, etcd, the scheduler, and the controller manager. Each of these plays a crucial role in maintaining the desired state of your cluster.
That's really helpful, Victor. Let's start with the API server. What can you tell us about it?
The API server is the front end for the Kubernetes control plane. It exposes the Kubernetes API, which is used by all the other components, as well as external users and workloads. You can think of it as the conductor of an orchestra, coordinating all the other components and ensuring they work in harmony.
That's a great analogy. So, if the API server is the conductor, what would etcd be in this orchestra?
Excellent question, Sheila. If we continue with the orchestra analogy, etcd would be like the sheet music that the conductor, API server, refers to. etcd is a consistent and highly available key-value store used as Kubernetes backing store for all cluster data. It's where Kubernetes saves all its cluster state and configuration data. Just as the sheet music contains all the information needed for the orchestra to play correctly, etcd contains all the information needed for the cluster to function properly.
That makes sense. Now, I've heard that Kubernetes uses a declarative model. How does this relate to the components we're discussing?
Great observation, Sheila. The declarative model is indeed a key concept in Kubernetes. It means that you declare the desired state of your system, and Kubernetes works to make that state a reality. This is where the controller manager comes in. It's like the section leaders in our orchestra, constantly watching the current state and working to align it with the desired state. The controller manager runs controller processes that regulate the state of the system, such as replication controllers for scaling and endpoint controllers for populating endpoint objects.
I see. So the controller manager is constantly working to maintain the desired state. But how does Kubernetes decide where to place new pods?
That's where the scheduler comes in. The scheduler is responsible for deciding which node should run each newly created pod. It takes into account factors like resource requirements, hardware, software, policy constraints, affinity and anti-affinity specifications, and more. In our orchestra analogy, you could think of the scheduler as the stage manager, deciding where each musician should sit based on their instrument and the needs of the performance.
That's really interesting, Victor. We've covered the control plane components, but you mentioned earlier that there are also node components. Can you tell us about those?
Absolutely, Sheila. Now let's shift our focus to the node components. These run on every node in the cluster and maintain running pods. The two main node components are the kubelet and kubeproxy. The kubelet is an agent that runs on each node in the cluster. It makes sure that containers are running in a pod. The kubelet takes a set of pod specs that are provided through various mechanisms and ensures that the containers described in those pod specs are running and healthy. The kubeproxy is a network proxy that runs on each node in your cluster, implementing part of the Kubernetes service concept. It maintains network rules on nodes, allowing network communication to your pods from network sessions inside or outside of your cluster.
Wow, there's a lot to take in here. It seems like all these components need to communicate with each other constantly. How do they manage that?
You're absolutely right, Sheila. Communication between components is crucial for the proper functioning of a Kubernetes cluster. Most communication happens through the API server. For example, when you use kubectl to create a new deployment, it communicates with the API server, which then stores the information in etcd. The controller manager, watching for changes, notices the new deployment and creates the necessary resources. The scheduler then decides which node should run the new pods, and the kubelet on that node is responsible for actually creating and running the containers. It's worth noting that this communication is secured using TLS encryption, which is a protocol that ensures secure communication over a network. There are also various authentication and authorization mechanisms in place to ensure that only authorized entities can interact with the cluster.
That's fascinating, Victor. It's amazing how all these components work together seamlessly. Now, I'm curious about some common misunderstandings or pitfalls that people might encounter when working with Kubernetes components. Are there any you'd like to highlight?
Absolutely, Sheila. One common misunderstanding is thinking that you need to interact directly with all these components. In reality, most of your interaction will be with the API server through kubectl or other tools. Another pitfall is underestimating the importance of etcd. Since it stores all the cluster data, it's crucial to back it up regularly and ensure it's properly secured. Also, people sometimes forget that while the control plane manages the cluster, the actual work of running containers happens on the worker nodes. Understanding this separation of concerns can help in troubleshooting and optimizing your cluster.
Those are great points, Victor. Before we wrap up, do you have any best practices or tips for working with Kubernetes components?
Certainly. Here are a few key tips. 1. Always use the API server to interact with the cluster, rather than trying to manipulate components directly. 2. Regularly back up etcd to prevent data loss. 3. Monitor the health of all components, especially in production environments. 4. When scaling your cluster, ensure you have enough resources for both control plane and worker nodes. 5. Understand the role of each component to aid in troubleshooting and optimization. Remember, Kubernetes is designed to be self-healing and automated, so trust the system to do its job, but always be ready to step in when needed.
Thank you, Victor. Those are really helpful tips. Now, I think it's time to reveal the answer to our quiz question. The component often referred to as the brain of the Kubernetes cluster is the API server. It's the central management entity that receives all REST requests for modifications to the cluster state. To summarize today's episode, 1. Kubernetes components are divided into control plane and node components. 2. Control plane components include the API server, etcd, scheduler, and controller manager. 3. Node components include kubelet and kubeproxy. 4. These components work together to maintain the desired state of the cluster. 5. Understanding these components is crucial for effectively managing and troubleshooting Kubernetes clusters. Victor, do you have any final thoughts before we close out?
Just one last thing, Sheila. I'd like to emphasize that while understanding these components is important, Kubernetes abstracts away much of this complexity in day-to-day use. The beauty of Kubernetes is that it allows you to focus on your applications while it handles the intricate details of scheduling, scaling, and maintaining your workloads.
That's a great point, Victor. Thank you for sharing your expertise with us today. To our listeners, We hope you found this deep dive into Kubernetes components informative and engaging. If you did, please consider supporting us by visiting crashcasts.com, joining our Discord community, or supporting us on Patreon. Your support helps us continue creating content to help you on your Kubernetes journey. Until next time, happy clustering.